and we have seen the VX combination as well, which is the hybrid of the V and X versions. We have seen several views and data initialization programs, by installing which it will reset all the data dictionary tables. Okay. If any part of the data dictionary you want to reset, we have the subscripts also, so you can execute only that particular part of the script and can reinitialize the data dictionary views or tables. And we have seen several frequently used database views, data dictionary views, the database, the tables, columns, indices, different types of indices, how we can find. And through admin, we have seen how we can get the data dictionary information with the single click of the toolbar buttons. Any questions, anyone so far? So today we are going to see the space technology and the capacity management. Okay, how to estimate the spaces. Okay, what are the views, data dictionary views you can use, and how through database administrator you can identify the space requirements. So we already covered it in the development, where we have certain knowledge about the space technology. We have three types of spaces: perm space, spool space, and the temp space. Okay. For each and every space we have three types of measurements: maximum perm, that is allocated perm, and the current perm, which is occupied perm, and peak perm, the space which was occupied at particular moment of time, which is maximum by the time. At some point of time, what was the space occupied, and later it may be occupying the less space than the peak, or sometimes the peak is also equivalent to current based on the situations. And similarly, the spool spaces. Spool space is the intermediary workspace used to execute the queries. Okay. So the spool space also has the same technology. And similarly, the temp space, which is used for only the global temporary tables. This space also has the three measurements: maximum temp, that is allocated; current temp, which is occupied currently; peak temp, once upon a time what was the peak it occupied. So here also you can observe the payroll is a database which has maximum perm allocated with 25 MB and maximum spool allocated with 50 MB. From the payroll, I want to create two child. First child is the page 01. So how we create? This is the syntax, the SQL syntax. Okay, generally we may not use this SQL syntaxes. We use the data administrator, or these SQLs are embedded in some stored procedures or macros, and we just pass the parameters. Okay, in real time, we generally don't use the entire SQL. We use the stored procedure by embedding certain statements and access and everything. We execute the stored procedure by passing the parameters so that it would create the user. Okay, so, but internally, this is the core SQL which will be executed if you execute the create user through any of the utility. Okay. So create user, username as password, and we have to specify from also. The create user from payroll with password from spool. So let's see actual syntax here, then we can get it more. Yeah. So how do we create user? You see the icon here, create user. Just give the parameters here, username, user1, owner. Owner means from which existing database or user, you want to create this user. Okay, let's suppose I want to create it from sysadmin is already having this. I have to drop some. Okay, so let us use sysadmin as a parent, and within sysadmin I want to create one user. So how I can do that? User mano 1 from sysadmin is the owner. It means this is the current or immediate parent from which the user mano 1 will pull space. And as we are creating the user, we have to give the password. I'm using same name, user mano 1. Pump space. Let's give 1 KB because I don't have much space. 1 KB. 1 KB. Okay. Account string, I will tell you later. The priority strings, profiles, roles, everything. All are not mandatory. We will see what all those things. Fallback. If you want fallback protection, you can mention it. Or permanent journals, before journal and after journal, you can mention it. Just click on create. See, this is the actual syntax what we use to create any user or database. Create user, username from sysadmin with pump space of 1 KB with the password of same user one I used, spool space of 1 KB, temporary of 1 KB. If there is any profiles, any roles, everything will be shown here, the production categories and everything. And then if you are satisfied with this, you can execute this. Run query. Then it will create a user. Okay. You'll see that in the users topic. But for now, you just understand this is the syntax how we create user, and we mention all the space attributes while creation of the user. Okay. So this is a particular syntax like that, and here you concentrate on these things: pump space, spool space, temp space. If you don't want to give, you cannot. I mean, you don't want. Otherwise, you can mention the temp space also here. Okay. And we have seen if the child is created with a 6 MB, so the payroll will be left with 19 MB. Right? And if I create one more child with 4 MB, then again the payroll will be left with 15 MB. Because the pump space is pulled from the parent to the child's whenever you create. But how about this pool? The shareable resource. Okay. All this hierarchy can occupy up to 50 GB. If all three together logged in at the same time, then all three together can occupy 50 MB. If only one user logged in at a particular time, he can go and occupy the whole 50 MB for his single user. Like that, 50 MB, the spool is shareable across all the hierarchical users. So it is very shareable resource across the hierarchy. If you want to give an internal limit, you limit it with a maximum limit. Okay, so even payroll 01 alone logged in, how much spool it can occupy, which is mentioned at the time of creation as a maximum limit. So even 50 MB is available when payroll 1 is logged in. It can occupy up to 35 MB only because it is mentioned as a maximum limit at the time of user creation. But for payroll 02, there is nothing mentioned at this pool. So by default, it can occupy its current immediate parent spool space. So it can occupy 50. It can occupy 50. But it can occupy only 35. So for spool space, there are two limits. One is the limit which is defined at the time of user creation. If it is not mentioned, then it will follow its current parent's limit. And one more limit we can say is the limit or the space which is available at that particular moment after occupied by all these users. Okay, so payroll is logged in and he occupied 40, and payroll 02 is occupied 10, and now payroll 01 came in. How much he can occupy? Nothing, because 40 is occupied by this and 10 is occupied by this, so there is nothing for payroll 01. He will get a full space error. So that is also one limit where we can mention the space which is available at that moment. Yeah. And then if you drop any user from the hierarchy, then the space will be added to the immediate parent. Okay, if I drop the user payroll 02, then the space of 4 MB which is created for payroll 02 is added again to the immediate parent payroll, so it will go to the payroll. So now payroll is left with 19 MB. So this is some basic concepts of the spool and the perm space. And sometimes as a DBA you will get many requests to increase space. Then how do you increase space? Do you add the space? Generally we will try to move the space from unused databases to the databases which are not having the space. Okay. So here in this example you can see this is DBA is the super application DBA, and human resource and accounting are two different databases within this DBA, different applications, let's suppose. Okay. And you are the administrator for both the applications. And accounting has already occupied its maximum perm space. Human resource does not occupy its perm space. Then what we can do? We can create a dummy database here. Let's suppose it is payroll here. Okay, we may create some database. Then you can give the rights and space from human resource to accounting. Who can do this operation? The SysDBA, which is parent of both human resource and accounting, and which has drop database access on human resource and create database access on accounting. Okay, so SysDBA login and it move the database from human resource to the accounting, and then you can drop payroll if you want, so that the space will be added to the accounting. Okay, so the payroll ownership is transferred to accounting with the command give. All descendant children of a given object remain with the given object. Okay, so when you give, the whole hierarchy will be moved along with its children. Okay, the give command may also be used to move permanent space from one database to another database. So this is the actual use of the give command. Okay. To transfer the ownership, we generally don't use give, because there is a drawback that with the give, the old parents would also have the access remained with them. Okay. The ownership is transferred to the new object, so both the objects would have access on the given object. Okay. So when we use this give, when we want to move space, we just create a dummy here and just move it to the accounting, and then drop it. The space will be added to accounting. That is the major purpose of the give command. And as we know, the spool space is a common resource in the hierarchy. When we keep on using the existing spool, at some moment, maybe after 1 year, after 2 years or 5 years, based on the usage, you may get a spool's error, right? Let's suppose right now I have 100 MB. On the first day I use only 10 MB. On the second day I use 20 MB. Third day 30 MB. So after 10 days, I will occupy all the perm space. so there is no spool available. What is the spool space? Basically, spool space is the unused, the pump space, right? If I have 100 MB, currently I occupy only 10 MB for the pump space, then 19 MB can be used as spool space. If I occupy 20 MB for the pump space, 80 MB can be used as spool space. If I occupy the whole 100 MB, then there is no spool space available. Okay, that is the relation between the pump and spool. The unused pump space is used as the spool space. Okay, so if we keep on creating the databases and if we keep on loading the data, at some particular moment we'll get a spool space error. For the SQLs which were executed successfully yesterday, today you will keep on getting the spool space error. Okay, and you observe no other user also logged in. You are the only user, but still you are getting this spool space error, and it is executed successfully for the last days. Okay, and it is an optimized SQL, but still you are getting this spool space error. That means the pump space is occupied by the data. Okay, to avoid that, okay, what generally the DBS do when the DBC is configured with all its default databases, before creation of the sysdba with the remaining space, they will create one more database called spool reserve. It is also a database and it occupies some spool space, like this. Create database spool reserve from DBC as pump space as some amount, maybe 20 to 25% of the DBC space. Okay, let's suppose if it is 500 GB, then it will be created with some 50 GB or 100 GB, the pump space. But we don't use this spool reserve for creation of the tables and to load the data. Just keep it. The spool reserve is for the purpose of spool. So the 100 GB out of 500 GB will pull and keep it as the spool reserve, and the remaining space we allocate it to sysdba. Okay, so out of this 500, the 100 is reserved for spool, and the remaining 400 or 350, because 50 MB is 50 GB is occupied for this, let's suppose. Okay, so the remaining 300 or 350 is given to the sysdba, and from here you start creation of your application databases. Then what is the purpose of this? Even if all these databases, whatever you created, occupy the whole pump space, but still you can have this 100 GB available at that moment. Right? If the upper limits are given for every database, they can occupy this 100 GB reserves. So you won't hit with the spool space error badly. So this is a typical best practice generally the DBS follow by creation of a spool reserve, and they don't use this database at any moment to load the data. They just leave it, so that at any particular point of time, even all the databases occupied their pump space, 100 GB is available for everyone. Okay. The rate of failure will be less, isn't it? Okay, so till yesterday I was able to execute a query with 200 GB, but now only 100 GB is available. Only that particular query will fail, which require more than 100 GB. But the queries which can be executed within 100 GB, they will keep on success. So the failure rate will be less, so you will get very less request. By seeing this request, the single request, you can observe, okay, spool space is already out of the range. Then you have to purchase space by getting approvals by LOBs, the business approvals, and then you add it. But during that moment, the small queries will keep on running. At least you get very less failures. So that is the best practice what they follow by adding a spool reserve in the environment. And while measuring the space, we have several data dictionary views. Let's see what are those views and how we use these views. The first view is the disk space and the table size and all space. We generally use disk space for database level space queries and table size for table level size queries. All space is also a view which comes with all the spaces along with a pseudo table called all. When you create a database and when you create tables, the first table is of 50 MB, the second table is of 10 MB, the third table of 40 MB. And once you create a database, what happens is pseudo table all will be created, and this all will hold the space of all these individual tables like sum of x, y, z. It is all internal process. Whenever you create a database, a pseudo table all will be created, and it keeps track of the sum of the space of each individual table within the database. Okay. And when you use disk space, the disk space should give the whole database space. So what it has to do, it has to sum up the individual tables. Okay. Instead of summing up individual tables, what it uses, the pseudo table size, which is all and which holds the sum of the individual tables. So directly picks the data from this virtual table or pseudo table all. Okay. So whenever you query the disk space for the current space, it just pull the data from the all and it will give you the size 100 MB, 50 plus 10 plus 40, and this all would also hold the sum of 50 plus 10 plus 40, so 100 MB is given. Good. And when you use table size, what it does, it has to calculate each table level space. So it has to display all the tables individually, 50, 10, 40, and if you sum up all these manually, then it will give you the database size. So this is one way of getting database size from calculating each individual table size. Good. And there is all space. When you use this all space, then what it does, it calculates each individual table size and it sum up the all also to that. See, table X, table Y, table Z, and it sum up all also. So it will show you the double the space of occupied, 200. Okay, so we generally don't use this. It could be some other purposes, but for us, we always use either disk space, which gives you the size from the pseudo all table immediately, and you may use table size if you want a table level detail, which gives you its table level. And these are some examples by using the data dictionary views to find the space. So this is the example for table size, and each this dictionary table or dictionary view will hold space of each table per amp. What does it mean? Let's suppose if I am creating a database X, and this X should be possessing the space of 100 GB, and in my configuration I have 10 amps, then how much space I should allocate for this database on each amp? It should be equally distributed, right? So for this database X, on each amp 10 GB is allocated, so that totally will have 100 GB. So whenever you allocate space, the space allocated will be per amp distributed. How the data is distributed, similarly the space also should be distributed. So when pump space is distributed across the amps, automatically spool is also distributed across the amps. So what is spool? Unused pump space for this database on each amp would become spool space for amp. Okay, so let's suppose for X I have allocated 100 GB of pump space, and in my configuration I have 10 amps. So this database will hold each 10 GB on each amp, and I occupied 10 GB of the data for this database, let's suppose. That means each 1 GB on each amp I occupied, totally 10 GB, and occupation would be 1 GB per each amp, isn't it? Okay. And on each amp 9 GB which is remained will be used as spool space. Okay. If everything is distributed evenly, this is the scenario. If I allocate 100 GB, each 10 GB on each amp, and when I occupy 10 GB of data, each 1 GB occupied on each amp, and 9 GB which is remained as spool space on each amp for this database, if everything goes in parallel. For example, if I skew the data for one table and occupied all 10 MB or all 10 GB in a single amp, but I didn't use any space of other amps, then if I keep on loading the data for the table, what happens? For one amp, it was almost occupied everything. All other amps are left with space. They have space, sufficient space. As per a bad index, all the data is going into a same amp. Skewness, highly skewed. Then what happens? If I keep on loading the data, I will get no room in the database error. Right? And if you observe, you occupied only 10 GB of space, and where you have maximum allocation of 100 GB, but why you are getting the error? You are getting the error because the per amp limit is already reached. Okay, this is also one reason why you get a no room error even you have space available for this database. Okay. In real time, what happens? You allocated space of 100 GB, and the developer is loading the data through fast load utility or some utility, and he is loading a 10 GB of data, and he is getting a no room error. Then he will come to you as a DBA. He will raise a request. Well, I am inserting this data, I am getting a no room error. Can you please check? Then what do? You will see the size of the database, it is 100 GB, and you see the size of the data which he is loading, it is only 10 MB or 10 GB. And then we will try to find out, okay, what happened. Maybe it is because of skewness, it is trying to occupy only one amp, and this amp limit is already reached. That's why he is getting the no room error. Okay, this is a real-time scenarios. Okay, what could happen at space level. Okay, so the space basically allocated on each amp basis. Okay, and these dictionary views also show you per amp limits. If you generally query it, okay, it will show you the vproc. Amp is nothing but a virtual processor, right? So it will show you each vproc level space distributed for each table. If you see how many vprocs are there in the system, 0 to 7, that means 8 vprocs, 8 amps. So if you want to find the table 2 size for each amp, you can see that here. Okay. On amp 0, table 2 occupied 127 KB and peak is 253. On amp 1, this is. On amp 2, this is. On amp 3, 4, 5, 6. But if you want to find out the whole table 2 size, what you need to do? You have to use the aggregation, the sum of max pump. Okay. So you have to use the sum of the vproc sizes, the sum of current pump grouped by the vproc, or grouped by the table name. So group by table name, you will get the sum of all the spaces occupied on each amp so that we will get the total size of this particular table. Okay. So that's where we summed up. Okay. If you see our query also, okay, which we used for spaces, we sum it up, right? Did you try this space SQLs? See why we summed up the current pump in the disk space and in the table size? Because in these tables it get each record per amp, so to get the table level we have to sum it up. Okay. And sum it up, and if you want to convert into MBs or GBs, you divide it with each 1024s. Like that you will get space in required format, but default it uses the number of bytes and each vproc level. Okay. So here disk space is used for the database level. Each database level, vproc level it uses, but here we use the aggregate function sum, so we are getting a database level space details. And then the all space we generally don't use, but this is the usage, okay, which will give you the all pseudo table details also along with the normal tables. And let's see how we use Teradata administrator to do it. Okay, through SQL Assistant, these are the sequels you can use, okay, by changing your database names in what you are interested in, or table names, okay, on what you are interested in. You can manipulate these queries. But if you want to use the Teradata administrator, see DBC, click on it and see table space. Okay, right click on the database, click on table space, which would give you the space details of each table. So what query it uses internally? The query on the table size, because you are querying the table level, so it uses the table size query internally and populate this data, current pump and peak pump. Then within this table you want to see the space summary, the same details, space by amp. We have 2 amps in the demo machine, so per amp details you can see here. The skew factors you can see here. What is the ideal skew factor? Can anyone respond? What is the ideal skew factor we expect? Is it a 0% skew we expect, or a 100% skew we expect ideally?
0 point something.
0. Ideal case is 0, but in real time it may not be possible 0 always, but 0 is expected. All data dictionary views, if you see, it is all 0. Very rarely you will see the skew factor. So this is how they design efficiently, right? So we also have to design our tables in such a way that skew factor should always be 0. The unique primary indexes will give you the skew factor 0, but there are other factors also to choose your primary index, the usage, right? So based on those two, you may get some skew factor. And if your table is very small, let's suppose we have 3000 amps in your configuration, but your table has only 200 records, then what happens? It is also skewed. Even though it has a unique primary index, only 200 amps it can occupy uniquely, but remaining 2800 amps are not having any data, so it is also a skew. So in case of a small table, we cannot avoid skew factor, so it is expected. But in case of the normal tables, we should expect 0 skew factor wherever it is possible. Okay. And From here, I want to see the child spaces. See, for each and every child, it will give me the detailed data of current pump, max pump, peak pump, maximum spool, peak spool, temp space, and peak temp. The whole data I can get about not only pump but the spool and the temp. What is the command? Select a database from which you want to track your application related. Click on this child space. There are no objects here, so let us see this object, child space. See, these are the childs of sysadmin, and each one is having current pump 0, so no data is there, and allocated pump is this, peak pump is this, maximum spool is this, peak spool is this, maximum temp and peak temp. Like this, they click, right click and click, you can see all the details of space here. How do you use this information in your daily activities? You will see every day for your application what is the peak occupied today and what is the difference between the max and peak for every spool, every space. Okay, if it is a spool, okay, what is the difference between max and peak? If they are going very close, that means you will be getting a spool space error very soon. Okay, so we regularly monitor the space for our application, for each database, for each table, to see is there any chance that we are going to hit a spool error very soon. If you observe this, okay, let's suppose the maximum is 6000 and the peak is almost 5800, suppose, then what is the alarm? Okay, next day you will get a spool error. So immediately we have to act, we have to inform it to the business owners to add space to the application so that they can go and purchase space and add it to your application. Right? This is how we use our space related details. And the capacity management. Okay, we can do the capacity management also by seeing these details. Every day how much spool it is getting, or how every day how much data we are loading. Okay, today 1 GB, tomorrow 2 GB, and day after tomorrow 4 GB, and day after tomorrow it is 8 GB. That can you estimate how would be after 5 days or 6 days? And can you see if that much space available here? Like that, you can forecast the space by seeing the usage patterns of the last 5 to 10 days. Okay. So that is how we use this space information to do the capacity management and forecasting of the space for the databases and the application entirely. Okay, you may use the administrator with a simple usage, or if you don't have access, you can use the SQLs to find out this space related information. Okay. Any questions, anyone so far? Good. Okay. So you do practice, just log in and try to find out different options in admin. So tomorrow what we are going to do, we are going to create a user with an hierarchy, and we'll see different parameters required to create a user, and the account strings, that is the priority strings, how we identify the priorities of the users while creation, and we'll go ahead. Thank you very much. So I'm dropping this line for now.